Everyone to my channel. Today we will see lecture 4 of our DSA playlist, and today we will discuss about merge sort. What is merge sort? Merge sort is a sorting algorithm used to sort array in either in ascending or descending order. And how does merge sort works? We will understand that through the help of an example. Let's take an example. 5, 7, minus 1, 6, 11, 0, 3, 9. Let's suppose this is an array or a vector, and we will perform merge sort on this particular array. Okay, so merge sort is based on divide and conquer algorithm mostly. What it works on divide and conquer algorithm. Divide and conquer algorithm, and uh, and at the end of divide and conquer, it merges the array. What I mean to say is, first it keeps on dividing the array in equal halves until and unless it is remained with only individual elements. What I mean to say is, if we divide the array into half, that will become minus 1, 6, and the another half will be, we further divide it. We just keep on dividing it until and unless we remain with only single elements, like this. And now, after we are only remained with single elements, we perform merge. From here, we don't divide the array further because we are only remaining with single elements. And now we merge the array. While merging, we need to keep in mind that the merging happens in sorted order. Means while merging, the elements are put in sorted order. How? Let's see. 5 and 7 while merging, it will give 5, 7 because 5 is smaller than 7. It is checked. Suppose if there are two pointers. That's it. Just give me a minute. Suppose this is a ith pointer and this is a j pointer. Then I and j are being compared is if I is less than j. Then put I first and then j after that. So what does it return? It returns back 5 and 7 as a merged array. I hope it's clear to you guys. Now same thing, comparing these two with I and j. What does the resultant gives? It gives back minus 1 and 6, right? Because minus 1 is smaller than 6. So minus 1 and 6 is being returned. From here, what is being returned? 11 and 0. Sorry, 0 and 11 because 0 is smaller than 11. So always remember it happens in sorted order. And from here, 3 and 9 because we are returning in sorted order. Okay. Now while going back from here, the merging will take place between two arrays. These two arrays, the merging will take place between these two arrays, 5 and 7. Our if pointer is here and our j pointer is pointing for this array. Our j pointer is pointing for the second array and our if pointer is pointing for the first array. Now tell me which is smaller, I pointer or the j pointer? Definitely the j pointer. So minus 1 is put first. First minus 1 comes, then j is incremented. Now j is here, j is incremented, j plus plus. Now tell me 5 or 6 which is smaller? Or definitely 5 is smaller, so 5 is put again. Now once it is put, then the I will increment. Once the element is put into the array, then that particular pointer is being incremented. So now I plus plus. Now I is pointing to 7 and j is pointing to 6. Which is smaller, j or I? Definitely j is smaller because j is 6. So 6 is put. And now since there are no more elements left in the jth array, so whatever remaining elements is present in the ith array, it's being put there. So only 7 is remaining, so 7 is put, and this particular is returned from this second step. This particular sorted array is returned from this step, and now performing the same action here, comparing with the ith and the j pointer. The I pointer is pointing here and the j pointer is pointing here. Which is smaller, I or j? Definitely I is smaller. So 0 is put, I is incremented, I is pointing towards 11 now. 11 or 3, which is smaller? 3 is smaller. So 3 is put here. Now j is incremented, 6 we put 3. Now 9 or 11, which is smaller? Definitely j is smaller. So again we put 9. Now since j in the jth array we can see, or the second array we can see, there are no more elements there. So all the elements from the first array will need to be put here. Only 11 is remaining, so 11 is put, and this array is being returned. So now the comparison will take place between two arrays, this array and this one. These two arrays, the comparison will take place. I hope you guys got clear. Now we are comparing these two guys again with the pointer I and j. I is pointing to here and j is pointing here. Which is small, I or j? Definitely I is smaller. So minus 1 is put. Now second, yes, minus 1 is put. Now tell me which is smaller. So I is incremented. I is incremented to 5. J remains here. J or I, which is smaller? Definitely j is smaller. So j needs to be put. Now j is incremented. Now 5 or 5 or 3, which is smaller. 3 is smaller, definitely. So 3 is put. Now j is again incremented since 3 has been put. Now 9 or 5, which is smaller. 5 is smaller, so 5 needs to be put. Now I is incremented since 5 has been put. Now 6 or 9, which is smaller. 6, definitely 6 is smaller, so 6 needs to be put in the array. And now once the 6 is put, the I pointer will increment again I plus plus will occur, so it is pointing now to 7. Now 7 on 9, which is smaller, definitely 7 is smaller, to put 7. Now since in the ith array there are no more elements left, so whatever is present in the jth array we will put there. 9 and 9 and 11, 2 elements are remaining, so we will put there. And this is our merged array that is being formed from this step, is being written to the main array. As you can see, our array is now being sorted. So this is the backbone of merge sort. This is how merge sort works. And I will also give you a code explanation, or I will write you the pseudocode for this particular program, how it is being done. It is done in 2 steps basically. First, we perform the divide and conquer. We keep on dividing the array in equal halves until unless there are only individual elements are remaining. And for the second part, we perform merge operation while going back or merging the array to form the main array. While merging the individual elements and forming the main array, we perform merge, and the merge is taking place in sorted order. Okay, I hope you got the idea clear. And for divide and conquer, for dividing the array, we perform a recursion based function, and the merge function is the normal function where we perform looping to perform the sorting operation. So without further ado, let me give you an overview how the merge sort program works. So first of all, how to divide the array, how to divide and conquer. So how to divide the array? To divide the array, we will write a merge function, merge sort function. In this, let us take a vector, and we need to take the vector by reference because we are performing the operation on the particular array that has been passed to us, on the particular array or vector that has been passed to us. We cannot create a new, at this point we cannot create a new. All right, now how it is being done? First of all, we need to be dividing the array in the merge sort function. First of all, we need to calculate the mid. And what is the middle point? The middle point is anywhere in the middle of the array. At that particular point, we need to divide the array. We divide the array from the middle. So we need the mid pointer. How we determine the mid pointer? Mid pointer is nothing but low plus high divided by 2. So what is the low? The low is the starting index of the array, and the high is the ending pointer or the end index of the array. That's it. Now once we got our min, we will perform merge sort again. Means we perform the recursion. Right? We perform the recursion, and the first partition, will be vector v. As we need to pass a vector just that from low to mid. The first partition would be from low to mid, and the second partition of the array would be from mid plus 1 to high, and the second partition will be from mid plus 1 to high. And then after after our merge sort is working and it has reached to the individual elements, we will perform a merge function. We will perform our merge function, and then merge function will pass our vector, our low pointer means our starting index, our mid pointer, and our last index high. And to stop this recursion, we also need to put a base case, right? So what would be the base case? We can say that the base case would be if low at any point is greater than or is equal to high, we can say we can return from here. Because if our low is greater than or is equal to high, it means that all the elements there is only one element present in the array. If at any given point our low is greater than or is equal to high, it means that there is only one element present in our array. So we can return at that particular point. Okay. Now, once our divide and conquer algorithm is being performed, means our partition has been done. Now we need to see our merge function. How our merge function works, how the merging is happening in sorted order, right? So to write that function, I will now give you an idea. Let's say void merge. We will again take a vector, and we will take our vector to reference. We will take the starting index. We will take our mid pointer, and we will take our ending index or the high. Okay. Now for here we need to take another vector or an array in order to store in order to temporarily store our sorted array. In order to temporarily store our sorted array, this portions, right? This small array that are being formed, right? This arrays that are being formed, we need to store it somewhere. After storing it only, we can put it into the main array. So for storing these arrays, we need to take another array or a vector where we will be storing them. Okay, and let's give it a size of 100 for now. You can make it large or small or equal to the size of the vector. It depends on what it depends on how much space complexity you want to save. We'll take more some pointers like int I, where I will be marking to low, int j, and j will be marking to the mid pointer, and the int k variable. Int k variable will be also pointing to low. We are taking it to put the elements in our array ARR, to put the elements in our array ARR and to traverse that particular ARR. we are taking that k element and it is low. Okay. Now while I is less than equal to mid and then j is less than equal to high. While I is less than equal to mid and j is less than equal to high, do what? Check that if v of I is less than v of j, because we are sorting in ascending order, right? Do what? If this particular condition satisfies, then do what? In the array of k, if the array k particular index, store v of I and then simply do I plus plus. Move to the next ith index. As we have also done it here in the same process. If I pointer is pointing here and the j pointer is the ith pointer is pointing here and the j pointer is pointing here, and whichever is smaller, we are putting them into our array, and whichever is smaller, we are putting them into our array and incrementing it by 1 and incrementing it by 1 if we are putting them. That what I have done in the code as well, as you can see. Now, if this condition is not true, then for the else part, that in the else case, what we will write? In the else case, will means that our here in the else case, it means that our jth array is smaller, so we need to traverse over our j and increment our j, right? So in the else part, we will simply write array of k store store b of j and increment j by 1. Once this if else condition is finished, then increment the k also, so that our array can go to the next index. Our while loop is finished. Now we need to perform one more check or two more checks. What will be the checks? While I is less than mid or I is less than equal to mid. Why we are performing this? Let's say if our jth array, if our jth portion of our array has been finished, but our I is still remaining. In that case, we need to traverse over our ith portion of our array and take that into our main array, right? So array of k is equal to v of I. Do a I plus plus increment I and increment k as well. So like both can go to the next index, and then while do it for the same opposite portion, when the jth portion of the array, if the ith portion of the array is finished but the jth portion of the array is remaining, so while merging we need to place those remaining jth portion of the array. So if j is less than equal to high, do what? Same thing in array of k, put v of j and increment both j and k. Now finally write one more for loop. For what purpose? It is for the purpose that in our new array we have taken the elements, right? In our new array we have taken the elements in sorted order, but we also need to do the same thing for our main array. So how will we do that? Int I is equal to low, I is less than is equal to high, I plus plus v of I is equal to array of I. Simply just this. In our main array, that is v, we will store the elements of our temporary array. Our temporary array holds the sorted array. Our temporary array now holds our sorted array, and we will store it back in our main array. That is v. Okay. I hope we got it clear. We will close our for loop and we will close our function, and that's it, guys. That's it. How our merge sort works. In detail, the code will also be present in the description of this video. You can check it out. And as for the time and space complexity, let's discuss about that as well. The time complexity. The time complexity of merge sort is for worst case. For worst case and average case, it is big of n log n. Where n is the size of the array, and why n log n? Because in order to divide the array, in order to perform divide and conquer, it takes log n time complexity. Right? It takes log n time complexity for performing the divide and conquer, and in order to merge the array, in order to merge the array, it takes n time complexity. It takes big of n time complexity in order to merge the array. And since before every merging the divide takes place, the division of the array takes place, so it is n log n. Now I hope you got it clear. And for worst case and average case, the time complexity will be the same, big of n log n. The worst case could be the array is given in descending order and you need to sort it in ascending order. And that is in worst case, average case, and base case. The time complexity remains the same, that is big of n log n. I hope it is clear for you guys. Now as far as the space complexity, what will be the space complexity? It will be simply big of n. Why big of n? Because if you remember, we are taking an extra array here, right? Here we are taking an extra array in order to sort our array. Please subscribe to our channel, and if you have any doubts or queries, you can comment down below in this video.
Eyes in the sky, gazing far into the night. I raise my hand to the fire, but it's no use, 'cause 'cause you can't stop it from shining through.